there's a latency issue. Okay, got it. Great. Well, Asif, I'm delighted that that basically you could join us today. Asif, Dr. Gill is a professor and head of the lab at the DigiSAS Research and Innovation Lab in Agile Software. He's at the University of Technology in Sydney, in Australia. He's an innovation advisor. He has a PhD in computing and a master's in business. Okay, for that, he's founding director of Infoagility, and he's an associate professor and leader of the DigiSAS. And he's basically working. He's I apologize. There's he's a leader of the DigiSAS Service Research and Innovation Lab. He's also an innovator. He spent more than 20 years experience in IT across different industry verticals. He specializes in agile software development, enterprise architecture, analytics, and governance. And he's working with a large number of small to medium enterprises and startups in Australia, helping them with their digital and innovation journal. He is known throughout. I've gotten to know him through Association of Enterprise Architects, ISACA, and the like. And it's been a real pleasure, and I'm delighted that he could basically come over and talk to us and give us a little bit of the insight into into solutions down under. So without further ado, Asif, over to you.
Thank you, Bob, and good afternoon, everyone. It's a pleasure to be talking on this event. And as Bob mentioned, I'm from University of Technology, Sydney. A bit of early morning for me today, and delighted to be speaking here. I'm director of the DigiSAS lab and also the director and the founder of the Infoagility. I have about 20 years or plus experience. I'm both academic and practitioner, so I'm going to share something today which is a bit of a mix coming from my academic experience, but also coming from my practitioner experience as a practicing architect. Just kind of move my slide. So, okay, that's taking a little bit of lag around there. Just quickly an agenda walkthrough. Today, I'll be talking about architecting intelligent enterprises, for more specifically from a strategy, architecture, innovation, how they work together. I will look at that. What are the key elements of an intelligent enterprise we try to architect and strategize, and how to architect that particular intelligent enterprise, and how to enable in particularly the intelligence in an enterprise. So these are pretty much a very simple 3 steps. I always love 3 points, which probably people try to remember. So looking at the intelligent enterprise, I just want to set the context, not to bombard you with a lot of definitions and stuff, but really we're looking at enterprise which has an intelligence capability. It's not about having doing algorithms or isolated machine learning and all these things. It's about having a very defined intelligence capability within the enterprise to enable that intelligence in that particular enterprise. And when we look at the intelligent enterprise, what are the key elements? So it could be a large or small or medium organization, but really when we talk about the architecting intelligent enterprise, we're really looking at the part of there, we call that the value creation part. And then the value creation part is underpinned by the structure, which an architecture need to look into that. This could be an individual organization or ecosystem view. In a government sector, it could be one individual department, or could be a government ecosystem. So looking at the structure part of view, but that structure is attached or offers some kind of a behavior that's where we're looking at the capabilities and process architecture of that particular structure performed by these things, by that behavior, by the structure. And then this behavior is offers certain kind of value proposition. It could be government product and services around there. And then the way of doing those product and services or value proposition, whether there's a purpose or outcome and impact we want to achieve. In particular, from a government point of view, we maybe focus on the outcome and impact around the social well-being of the citizens, or a betterment of the economy or environment. It could be different. And all these things for an intelligent enterprise, they are underpinned by the information. I'm using the word information because it's more inclusive. It includes data, analytics, and intelligence pieces. And then that information helps to make informed decisions. And those are enabled by the technology underneath that information technology combines together to support the whole 4 item. And the whole purpose is that all about the value creation. I'm just going to relate for my next slides to set up a little context for further discussion of this presentation. I will set a little insurance case study. I use that based on my experience in the industry, and we can relate to the government ecosystem or government as well. Whether you are looking at from a government point of insurance internally, especially we have NDIS, National Disability Insurance, or other kind of thing, schemes in government they offer. But really, is without any specific purpose, the focus is that just to set up a little context, and then I can run through the approach around that. So I'm taking that SFS insurance case study as an example. It's a fictitious organization. For example purpose only here, let's say having over 40,000 employees working in different locations across the globe, Asia Pacific, Europe, and US, and they offer different kind of small personal and corporate banking services to their customer via online and in-branch channels. And the channels are categorized as, let's say, direct, group, and retail. And the major financial services, they include insurance, investment, and superannuation, retail, advisory, and others. So really, this is really for me is setting up a context which will help me to understand, to elaborate and demonstrate some of the things and concept and tool I'm going to discuss today. So the purpose of SFS insurance case studies that first of all highlight their strategy or vision. They're very keen to transform their insurance business using emerging digital technology. And that's there for certain purpose to enhance operational excellence. That's one of their value proposition is around there, or value outcome. And there's a growth for competitive advantage, mean adding new product or services to their portfolio, both in local and international markets. So that's their vision is around there, which is really forming based on their strategy. And then there's the planning, and to deliver that strategy, we need to have architecture and innovation capability around there. I bring architecture and innovation together because innovation is not about bringing another app or other small module into the play or feature or user story or module. It's about building the innovation in the design of the architecture of your organization. That's where it's a design level innovation, and then that design can be implemented and planned around there. So that's where the strategy to planning or vision to planning is delivered via architecture innovation. That's what this bubble is around here. The challenge from a planning point of view is for that SFS insurance is that they're not sure which parts of their insurance business should be transformed using digital technology. Imagining a government department having thousands of applications and hundreds of business capabilities, or maybe a handful of departments or units. So which part of those would be transformed digitally? So that's where the architecture and innovation going to come into play to answer some of those questions. So this is really setting up a little challenge for us, and then we see how the approach which I demonstrate today can help us. So architecture approach, we all familiar probably maybe so far in the conference has a lot of enterprise architecture flavor. So enterprise, there are a lot of frameworks. There's not a shortage of frameworks. This is one of them as well. I call this meta framework from this emerged over a period of last 10, 12 years in my own practice. There are different layers in any typical architecture framework. Here I have interaction architecture layer, then the human layer, technology, facility, and environment layer, and that all secured by the security layer. So really the interaction layer is a touch point when we're looking at the architecture, and it combines all the other layers. So today I will only focus on the interaction layer. By all means, you can look up on the other layers as well, which I published over a period of time or spoke about in different industry and government events. So here, these labels will help us to identify which parts to digitally enable and how much. So that's where we're looking at the digital maturity and the performance outcome attached to that as well. So really architecture help us to look at our enterprises and look at that, which parts, and that could be at the layer level, and layers could have underpinning elements as well, which elements need to be transformed. Going back to our financial services example, that financial services organization operates in a financial ecosystem. So it's very important as an architect or planner, we need to look at our enterprises or our individual government departments as a part of the bigger ecosystem, because we need to share data, we need to share services, we need to integrate with us. So all the things require a more ecosystem thinking rather than just the internal one unit or one single enterprise thinking. So here, that insurance organization is an insurance provider, but then there are NGOs, businesses, individual partners, regulators, the government as well. They come into play, who they interact with that as well. So we need to consider before we are architecting our enterprise, we need to consider it as a part of the whole ecosystem rather considering it as isolation. So when we look at the enterprise and ecosystem, especially that SFS financial services case study organization point of view, there could be a different angles to it. So in between here, architect of the enterprise could involve these layers: human, facility, technology, and the interaction enabling everything, which are here, and they're securing those interactions with those elements. But then also, who is interacting with that? That we really need to look at that. We could have economists, politicians, regulators, communities, suppliers, partner, competitive startups. We have employees and volunteers, we have customers or users. So you can see that there's a whole lot of actors playing in that ecosystem and interacting with these layers, and those layers are locked via or secure via the security layer. So that was all about adaptive EA. It adapts to different things, or adaptive enterprise architecture approach. As I mentioned that in this particular presentation, I'm only focused on the interaction layer, and you will find later on, because there's a lot to cover if I go across all the layers, and this layer also interacts with every other layer. So that's probably makes sense to me to just explain that. But here it's really important is that one thing is you consider the enterprise operating in an ecosystem, but also looking at that from an intelligence point of view. We need to look at that adaptive enterprise architecture as information. Architecture is always about pretty diagrams or PowerPoints or static diagram. There are a lot of modeling languages to do that. But really, when it comes down to the really working of the actioning of the architecture, it's all about the information. So how we can represent the architecture as information. And when we talk about that, the purpose is that we turn that architecture into data to analytics and intelligence. And then we look at that in analytics and intelligence of our data, of architecture data, to make decision and respond to whether different technology and non-technology needs, including the digital transformation. And this cycle goes across all the layers. So important is there from an adaptive architecture point of view, we need to consider that as an information. So it's not about static diagrams or model. So interaction, human, technology, facility, environment, security, we can burn into or convert into a data. Once we convert into data, we can apply analytics and intelligence. And that's the really first point of when we architecting intelligent enterprises, we start considering our architecture as information. When we look at the information piece, I will quickly jump onto that. It means data analytics and intelligence, and that enables the decisions and decision for change. When we look at the adaptive architecture or architecture of our organization, architecture is all about change. It's about ability to respond to those changes and plan it and architect it and implement it and operationalize it. So all there are a lot of decision around those changes. So architecture information can help us to make those decisions about the changes, including digital transformation. So now bringing that together, we need a framework to channelize or streamline the thinking, which I mentioned in previous slides. So this is one of the framework which I developed, which I've been using for a long time in different industry and academic, but industry-sponsored project. So really it comes down to 6 things, categorized around 2 big items. One is it's about the design. We design the architecture, and then second is that about the practice of designing that. So this is all about, for me, enterprise architecture, and it has 6 key components. Any architecture practice needs to start with principles, which can guide the design, and then the meta model. What could be the information we're going to capture about our architecture across different layers? I mentioned that in the previous slide. Not all the layers might be relevant to you. Like today, I'm talking only about the interaction layer. So this is all about the design. These things, it's not a really large, chunky enterprise architecture. It's about really bringing things down into simple things, principles, meta model, and layers. That's the design. And then we're looking at the capability, our architecture team, or a practice or operating model that comes here, and that can generate different architecture products and services, what we call a pipeline. And those services are being consumed and available for our enterprise. So really, this is about the practice of architecture. This is about the design of the architecture. I just going to jump into a little bit more of the pipeline, because pipeline brings together everything. It's just a pipeline of a delivery of architecture services and products. So whenever I deliver a project around architecture, we're looking at the vision and scoping of that project of architecture. Then we go about discovering the data and doing the modeling of the architecture. Again, architecture is information modeled. And then we look at the future and the current and the target and transition, states, maturity, and all these things. And that can help us to do the implementation phase, where we're looking at the roadmap. And all those things that govern and adapt as we go. So it's not about a big architecture or just in time or minimal viable architecture. When we look at this cycle of architecture pipeline, it is about the pipeline of a minimum required architecture for value delivery. So that's what we really need to focus on. What is a minimum required architecture which we needed to answer our concerns or to make required decision at a given point in time? There's no point of boiling the ocean. We need the information to clear our unknown items when we're making a decision. So really, you can run this pipeline iteratively. I normally run bit for 12 weeks, a kind of a time box release of the architecture, which we call minimum required architecture release for value delivery, but you can tailor as per your own organization's internal methods, because this pipeline needs to be connected with the project delivery pipeline and the strategy pipeline and the operations pipeline as well. So all they need to connect together. So this is a pipeline, we can use it, but let's look at the intelligence enablement. So when we consider architecture as information, we do not have to start from scratch all the time to do the models from the very beginning, but really what we needed to focus on that, we can make use of our operations data. What is the current? So operations are of a current state architecture, and we bring that into our historical or a current design information, and then architecture of the future can be deployed into operation as well. So that's what we call RCOPS. So to cut down the time of your data collection about architecture as information, you use your operations data. And that's really a concept of RCOPS in addition to a DevOps, what you are already probably familiar with. When we use that architecture information, we can generate different models. We first of all construct the architecture data models and link them together. And then we analyze that data doing data analytics. We can do different type of data analytics on the architecture data, interpret and analyze those analytics. And then also we can apply machine learning and AI to that, and then analyze. And then finally we decide and respond to different opportunities, including digital transformation and innovation based on that information coming up. But here we define what information is that based on whatever information needs are based on all the intelligence, and that information is feed into our decisions, which could be different models and actions, and the action attached with the what performance outcome we want to achieve. So action is always about what performance outcome we're going to achieve. It's not for the sake of doing things. Sometimes we do for compliance purposes, but also the outcome is that we're being compliant and being safe and not being penalized or fined. So that's really the concept, is that adaptation occurs based on the whole behind the scene data analytics and intelligence pipeline of the architecture information. And this is just a summary of that. Architecture information modeling could be at the conceptual level. We can use language such as Archimate to do that. We can convert that conceptual model into the data graph or graph. Graph or knowledge graphs are a really good way to represent the architecture information, because architecture information is about elements and their interactions or relationships. So graph is a really good approach to actually model that. And once you have data as a graph format, you can analyze that data. You can apply AI and machine learning. You can apply decision models and other things into it as well. There are different tools to support that architecture information modeling. Of course, Archi for good for conceptual Archimate modeling, but then there are other tools as well, including Abacus, Jalapeno. It's not in any order. I'm just giving you an example. And then Neo4j, that's where you can store your graph data about architecture. ServiceNow may provide you operational or current state of the architecture data from your operational CMDBs or repositories, and their analytics and AI machine learning platforms. All they can help you to develop architecture information viewpoints and views, and based on the meta models, data effects, and other things. And all this, what we do is a purpose to address stakeholder concerns or questions. So this drives what could be views and viewpoints you can develop for the architecture using different technologies. So this is really your pipeline. So architecture is a simple, in a sense, it's all about answering the question. As an architect, you go about develop different viewpoints and views based on the data using different tools and technology. Here is an example of a consolidated architecture information platform model. What you can develop as a how you manage your architecture information. So your architecture information might be sitting in different sources. It could be strategy, architecture, project, operational requirements, enterprise system, CRM, SAP, ERP, all these kind of things, or Salesforce. So how you can integrate that information using your process layer here. And that's where you can have an architecture, enterprise architecture knowledge graph. And here you can build that data catalog and metadata and the data about the different sources. And through integration layer, you can map here. And this layer, then enterprise knowledge graph, can serve and search via search and discovery capability, or reporting and visualization of your architecture information using this knowledge graph, and intelligence and analytics you can be processing through this layer. So rather than storing all the data around here, you only maybe store necessary data, master data about your architecture, and also the metadata about the architecture resources and the information where it goes. So this enterprise knowledge graph could be developed as a conceptual ontology, which can also have the metadata as well to explain the data sitting in different repositories where you can integrate it. Here is an example of a architecture information graph. Again, I did that in a Neo4j database. You can see there are different meta model elements, which are in the blue color. And then there's a data, which is the instances of that. So actor, you can find it. Actor could be a type of a person. Person is a type of an actor. And then there's another data, customer. Customer is a kind of a role which an actor perform. You might have an employee as a role over there and the further roles over there. So the things which are in the blue, they are the kind of a ontology, and plus the data is all those the instances of those ontology. So all these things could be considered as an enterprise knowledge graph, data and the ontology which describe the data. Plus also here we can map to a different connection to a different sources as well to complete this enterprise knowledge graph. And you can see that knowledge graph is all about their nodes and their connections between them. That's how it is simple as that. In a sense, it's all about nodes and the source and target node and the relationship between them, which you capture. You can capture properties about the nodes and about the relationship as well. There's a more extensive example of that. Here I expanded that knowledge graph, and there you can see that it could be a lot of other concepts could be added and instance could be created, and those instances could be mapped to the actual data sources. So that was about the architecture approach so far, using architecture as an information, and then also using analytics, machine learning, conceptual modeling, and the data modeling, other things to represent your architecture information. So far in the presentation, what I said a foundation is about, we consider architecture is another important piece of our information in our enterprise, which needs to be properly managed, governed, and operationalized and used. If you are not using that architecture information effectively and we're making more of our decision without the evidence, that probably maybe this is an opportunity to actually consider your architecture information more seriously and having a more managed approach to architecture information, because this is the design of the enterprise, which we need to manage the information about it. In this, the last piece, I will discuss the interaction architecture as an example applicable to that financial services case study. Again, highlighting it's all about interaction architecture as information, how we represent that. So architecture, information models as artifact, what we produce. It's about the interaction of the systems and all these things. We can create different models. So there are at least 4 types of models. There's a data model of the architecture, there's analytics models, and there's the intelligence model, and there's the adaptation model. And there's a visualization and storytelling about those models. So if you look at the interaction architecture, so I just gave you an example around here. So SFS insurance company can interact using different channel, their customer, through different touch points of awareness, get quote, purchase, claim, renew, and cancel their policies. Simply, you can think of your own channels of your organization or capability area, and what are the touch points are, where's your end user or customer employees interact with. So that's your starting point to picking up that channels and touch point data about the interaction architecture. Once you have those touch points, you can see on my left side, then you have the data about that of the digital interaction architecture data. Then you can perform different kind of analytics on that. You can describe the interaction data. Then you also apply diagnostic models on that. You maybe have a hypothesis and root cause analysis of the customer complaints during interactions. You can also look at the data analytics from a predictive point of view. You maybe use different methods, moving average, straight line, regression analysis to forecast the interactions, and predictive revenue coming from there. From a government point of view, you might be looking at your revenue department, which interactions are bringing the revenue to the department, or maybe bringing more customer satisfaction when you are dealing with that, or citizen satisfaction. So you can see that here, interaction could be different in your own context as well. And then there's an analytics from a prescriptive point of view, where your recommendation engine or something you can use to suggest actions or transforming, improving, growing, sustaining, or retiring the interaction, certain interaction you want to keep doing, certain interaction you don't want to do, a certain new interactions you're going to evolve, or certain interaction you're going to be improve using different things. So that's really a prescriptive analytics you apply. Also, you may want to use AI. You can maybe embed customer feedbacks or other things. You can use natural language processing to recognize the pain points and other sentiments in interactions on your interaction architecture. And then you're looking at that data intelligence, which is machine learning. You can classify and cluster certain interactions. Here you can say with the interactions and the revenue example I'm giving. But you can cluster your interactions or group interaction with the highly valued services interaction with the citizens, or the less value or less likely occur interaction with citizens. But here I'm looking at interactions, maybe a higher revenue interaction, medium revenue interaction, and low value interactions, or it could be complaints, where are more complaints than the others. And then finally, we come into the play. Based on all that information, we can have decision models. We can have decision matrix trees and stuff for identifying the interaction architecture transitions for the roadmap. And based in this example, which I'm sharing with you, I identified 3 transition states based on all these analysis. I'm going to give you a quickly rundown of that analysis and examples of those models, some of those models which I can represent the concept, put it into this data to decision kind of architecture approach. So here I have first of all collected, I would say that it's a fictitious data I'm showing. Don't want to jeopardize any kind of privacy and stuff. So interaction architecture, data analytics point of view. So we have, let's say, touch point data. There are a number of interactions mapped to each touch point. And you can see that more of the touch point have interaction is around these, the 3 tops: awareness, getting code, and purchase, but the less are on the other side. The data is a bit skewed around on this side. And then we have diagnostic analytics we can perform. We can look at the complaints of the customer around this interaction. And we can say clearly here, claim is an area where we have more complaints. And then we can further analyze using hypothesis testing. We can have a hypothesis, maybe the average time to process the insurance claim is 30 days. You can look at the hypothesis for your own environment as well. Average time to process a service request in your organization as a government department or government service department. So where here we can have some kind of a hypothesis we can have there as well, and some kind of a p-value is there. Based on that, we can say that whether this hypothesis stands or not. And then another hypothesis that more than 80% customers prefer technology interface for lodging the insurance claim. And that we can also look at that. This information could be really good. If more people prefer technology interfaces, mean going digital is very good option for us for digitizing those interactions. Also, we can look at that. What's the link between the interaction, the revenue? You can see as the interactions are increasing, revenue is also increasing. So this is again a part of our diagnostic. Further, our complaints, we can look at their causes of those one. What is the complaint? Because of the people and the process issues, information technology issue. So we can do root cause analysis around here. So this is all about diagnostic analysis on your interaction architecture data. Then you can also look at that more predictive analytics, and you can forecast the revenue around there using different methods. I use here straight line method based on the previous year's fixed growth rate. And I can see that based on the same growth rate, revenue was initially 100,000, let's say, in 2020, then 105 and 102.50 as it going more as it goes further, 110 to 50. And then similarly, we can use moving average for last 3 months average we can take to predict the next few months. And then again, the last 3 months, 6 months, we can look at that to forecast the rest of the year or next month. So the bit of a revenue forecast could be short here as well. Similarly, we can do linear regression around there, or for predicting point of view. You can see that as we already identified in diagnostic analysis, more interaction means more revenue. So you can see that based on that, we can develop that regression slope and equation. And based on that, we can say interactions, a number of interactions and the revenue they can bring, and that's how we can do what if analysis around here as well from a prediction point of view. 50 means 50 interactions mean the revenue would be around that much, where the more interaction mean more revenue. So we can look at that angle. So here what you have seen so far, architect is not about drawing pretty diagram. They are about modern day architects that need to be able to work with the data and help the organization to understand and make decisions about their architecture design, about the interaction design of the business architecture design or information architecture or technology or whatever. I'm happy to keep going. If people can ask me question in the end, as I was advised, but please make a note whatever the question you want me towards the end, and I'm happy to share more as much as I can within this limited time. I'm not far away from wrapping up. So here's an example of prescriptive analytics. Here we can see that we can have a data coming from different architecture information elements and the descriptive, diagnostic, and all these things, and predictive. So all the data we can then plug in to answer our prescriptive questions, like what should we do to improve our customer engagement? What should we do to improve interaction across various touch points? So you can see these are the question we have. We need some kind of a recommendation from a system or prescriptive analytics to be able to answer those questions. And we want to answer those questions because we have a strategy linked to it. There's a strategic goal around there to do that. And then what kind of a prescriptive analytics we can do? We can do goals and KPI analysis. We can do constraint and dependency analysis, pain point and value point analysis. We can look at the current maturity and in-flight projects analysis, what if analysis, and in the end, output we want, which interaction we need to keep as sustained, which interaction we need to transform using digital technology or improve it, or some of the things we should not be doing, which is retired, or which new interaction we need to introduce in the context of interaction architecture. Same can be applied or similar can be applied to other architecture layers. Here's an example of AI, how we can apply AI to the architecture data. Here you can see that I have customer complaint and feedback text coming on, and I can apply natural language processing from AI, and we can apply to those feedback items that NLP, and based on that, it can NLP tools or approaches or methods can help us to classifying them around different topics. Like this was about awareness, this complaint, this was about claim, this was about purchase. And then the sentiments are further there. They're not only classifying, but also whether they're happy customer. So these interactions are not happy, the negative sentiments, but this was a positive sentiment. And some of the keywords we can pull from our data as well using NLP. Let's say they're talking about inconsistent product information or user interfaces and pages. So these are the slow response on the claims. So they are the pain around there. Where the other kind of keywords we can look at that, there was a product purchase and good value for money. So all this can go into NLP matrix and map to different interaction and different channels. And then we can see that which areas we need to uplift. And further to that, we can also use clustering, the interaction data, architecture data using machine learning. You can see that 3 clusters are identified using clustering approach from machine learning. A cluster, this top cluster is a high value interactions. And then there are medium value interaction based on the revenue, average revenue. And there's a low value interaction based on the revenue. You can have similar clustering approach applied to your own interaction architecture data or a business architecture data for your own department or organization. Here's a little example of a decision. Once you over all the architecture information model come there through, you have those transition analysis. What you need to do now? Well, you need to introduce a change. Based on the data you have, what decision you need to make. So you can look at the different options analysis from your architecture point of view, and then look at each option and the change impact, the business value of that change, feasibility, importance, complexity of the change. Are we ready to take that change? What is the risk involved in that change? And resilience. If we fail, would we fail safely? And we bounce back or not, restore or not? So this can be across all the options you have based on the data you got it. And based on that analysis, I identified actually 3 examples for the transition state. And I'm looking at AI-enabled interaction. First of all, enable conversational AI capability for awareness, because there was an issue with the awareness touch point. Implement recommendation capability for purchase and renew state, because renew has a bit of and purchase have a bit of a improvement opportunity based on the complaints we have or pains we have. Then we implement a image processing capability for claims area. Claim was a highly complaint area, so we can look at the AI embedding technology, digital technology, to automatically recognize the claims, and if there is images or photos provided by the customer, so we can process that quickly rather than humans looking at there. I mean, human can look at that as well along AI to make sure the process is speed up. Rather than 30 days, can be reduced to 15 days or 1 or 2 weeks. And all these transition state can go into the roadmap and implementation plan. Further, those 3 things I identified, initiatives, transition state, I can map onto my decision matrix. Here's an example of decision matrix. There's a change, and then there's a business value, low to high and low to high change. Here we have a high change and high value. And here we can have the box where we can organize our initiatives where we have a low change but the high value. These are pretty much a low hanging fruit. These things we normally like to do first. And this probably second because there's more value around here, around these boxes. Here we have a medium level of kind of a gain, a low level of a gain. So this might be, that's why it's a third priority to implement that. And here the things which are in this quadrant, high change but low value, we tend not to do those, implement those initiative or changes. So this is how you can plug in your data-driven initiative on a decision matrix, and then you can make decision, and you can plug in onto your larger roadmap. You can say that, hey, the interaction architecture layer, there's a business information. I did not discuss that, but I discuss all in my book, this whole example, which I shared it towards the very end. That's where we're looking at the only interaction. Interaction, I identified these 3 new initiatives in a certain order. You can see that from 2022 to 2024, we need to implement them, these one, but also there were other in-flight existing initiatives as well from last year or previous 2021, defining interaction strategy, defining interaction journey. And also you can see some other business and architecture level information architecture can inform the decisions as well. So this is all explained in my book. I just pick up this piece to share with you how data-driven approach can be used to do architecture and roadmaps. And also when we look at the implementation plan, it brings together everything. It brings together strategy because it link up your initiative, new initiatives, which you identified from your architecture data analysis, link back to the strategic, your goals and priorities, which are here. I mapped around here. Also your tactical pain points or operational pain points. And then there's architecture where we're looking at that. What are the different candidate capability areas, maturity level in the architecture and technology candidates. And then there's the innovation piece, which are, these are the innovation initiative. So that's how strategy, architecture, innovation link together through an implementation plan. Finally, as I mentioned, this whole thing covered in my upcoming new book. This has already been available online. It explains the whole case study in the putting it all together and explain all the components as well. It's pretty much simple. You define, you need to have your own framework. You have a mindset of being adaptive, and then you have principles to guide your design. You need a meta model to capture that, your information about your architecture across different layers. And this is all cover your design. Then you have to do the thing. You need a practice, architecture practice. You need a capability or team or operating model of architecture, centralized, federated, whatever works for you. And they deliver the architecture artifacts or pipeline. And this pipeline also needs to be integrated with the strategy pipeline at the upstream and the downstream, with the development stream or project delivery stream or operation stream. And these are the different architecture services offered by the architecture team. And then this is putting it together. So this is pretty much what I explain here in this presentation, as some pieces snippet from this putting it all together item. There's some other case studies as well. You can look at that. This was from one of the central bank I worked with. We did that business technology services data, and the data were pushed up. About bank has about 220 or 25 plus services. How you collect data about it, and then you look at the service-oriented architecture approach to map their data, map their architecture, and each service has their information. And service has all the dependency and different layers of the architecture. You can look at this article for further information. Similarly, this is a digital identity verification. Again, this is a project again with another industry partner company called DataZoo we were working with. It's a digital identity verification across different ecosystem. I'm pretty sure Canada has their initiative in government digital identity. We have as well in Australia, MyGovID and others. And this is one of the private provider who we are working with on digital identity verification. This is a key to enable digital economy across the globe. And finally, it's time for me to reflect, and you might have questions, but also architecture is a reflection of your operation, what you do. Architecture in documents is a waste. Architecture in operation has a value. That's really the mindset I would like to have. There's no point having a 200, 300 page architecture document if you can't operationalize it. That's pretty much from my side, Bob. I'm happy to hand over to you back to, if there's any question, I'm happy to take question. Here's some of my detail. I don't mind being LinkedIn or by Twitter or reaching out to me. via email. Happy to have a chat, anything. Happy to share more mindset around. Thank you very much. Bob, over to you.
Well, thank you very much, Asif. That was quite a tour de force, as they say in French. I mean, basically, what happens is we covered a lot of ground, but it's really interesting, and I'm certainly going to be looking for your book, to provide insights. One of the questions I have, okay, just a second, we're starting to get some questions here. One of the questions that I have just immediately is, you've got the copyright at the bottom. How much of this work can basically be used in government?
I think copyright is just for the sake of the authorship, but this, since I'm presenting here, is publicly available, even the book available, so method available. So please use it. Just acknowledge the author or the source,
Okay.
which is, of course, that's it.
Okay, for all people in the audience, what we're trying to do is basically create a Creative Commons 4 so that these resources can be used, but with attribution. Okay,
Absolutely.
that's the important part. Attribute.
Yep.
Okay, and I think most people in universities are, that's what they want. I mean, they don't just create the knowledge; they want it to be used. Okay, for that. Now we have a question. Although the public and private sectors have some features in common, but their differences are more than their similarities. That's conjecture. It seems that business value is more appropriate for private sector. Do you think it's good for the public sector?
Absolutely, Bob. I think that's a very good question. And I think I have been involved in a lot of government projects, including the central bank project was there. I think the value is that there's a business contributing to the government operations as well in terms of the tax paying and all these things. So we need to ensure that there's a good business value for the money. And I think that's where it's really, really important, the business value for the government as well. But at the same time, from a government point of view, it's about the value for the citizens we are enabling the economy and the ecosystem who can help them to generate value, business value for their own business, including startup, SMEs, and all these things. I hope, and this is a good point, because the government needs to think about not as a government, but need part of the ecosystem. That's really the architecture approach is that here.
No, I think that's a very good answer, and I'm certainly going to be addressing that particular issue in innovation and digital transformation, because innovation in government, how would I best describe it? The drivers for that are not the same as in the private sector, where essentially innovator or go bankrupt. I mean, that's basically the metric. Let's see if there's any other questions. Sorry. Okay, well, thank you very much, Asif. I appreciate your getting up at dark 30 just to give us a presentation over here in North America. It was greatly appreciated. And hopefully we can, anyways, we'll be staying in touch, in contact with one another. Looking very much forward to it. So thanks again for your effort. And then what happens is we'll post it if we can put Creative Commons 4 on it, that would be greatly appreciated. Or use with attribution, that will be super. Okay, so thank you very much. And ladies and gentlemen, this concludes the day one. We have 2 more days, lots of exciting presentations coming up. So I hope to see you tomorrow morning, where we start off with Dr. Alvin Marcello from the Philippines. And he's going to be talking about the e-health governance. It's called through peer learning network. So basically it's the Pan-Asian e-health network that's being set up at this particular point in time. Fascinating topic and fraught with all sorts of challenges. Okay, well, thank you very much. And good, see you tomorrow morning. Take care.